Okay, we're going to look at something that's called holes that can happen in your rational functions. So if you remember, before we said that we can't have any factors in common. Well, now if the numerator and denominator have a 0 in common, there will be a hole in the function's graph. So a hole is like a section of the graph where literally there's a hole. So it does not exist at that one singular point. To graph the function, we're going to factor the numerator and denominator to find any common factors, and we're going to find the hole by evaluating the new function, which is created by canceling the factors at the undefined value. So I'm going to lead you through the front page 1 through 4, and then you are going to complete only questions 1 and 2 on the next page as kind of our holes part 1. All right, so let's take a look. We've got these two different quadratics. We're going to have to factor them first. So it would be good practice for you if you paused the video, practiced factoring these quadratics, and then check your answer. So take a moment to try factoring them yourself. So now I'm going to factor them. This one factors into x minus 2, x plus 1, and the denominator factors into x times x minus 2. Can you see the common factors? X minus 2. So my new function, see up here it says new function, right here, new function, is y equals x plus 1 over x. All right, so we're going to answer the same 4 questions, the y-intercept, the x-intercept, the vertical asymptote, and then the horizontal or slant asymptote about this new function. And at the very end, we're going to figure out the hole. So you may want to pause the video and try these 4 steps on your own just to keep practicing those 4 steps. So now I'm going to tell you the solutions. For the y-intercept, when I plug in 0, I get 0 in the denominator. So there is none. For the x-intercept, I want -1 because that's what makes the numerator 0. I'm going to plot that on the graph. For my vertical asymptote, it would be at 0 because that's where the denominator is 0. And for my horizontal or slant asymptote, the powers are equal in the numerator and denominator, and 1 divided by 1 is 1. So y equals 1 is my horizontal asymptote. So now I'm going to figure out my hole in the graph. The hole in the graph occurs where this original function was undefined, which would be at +2. Can you see how that would be 2 minus 2 in the denominator? We canceled it out, so we don't even see that happening over here. But because the original function was undefined, the new function will also be undefined at that point. So we're going to plug in 2 into this function and see what we get. We get 2 plus 1 divided by 2, which is 1.5. So 2, 1.5 is the location of the hole. 2, 1.5. So that tells me that this region of the graph is this elbow, and this region of the graph is this elbow. And now I'm finished. Okay, example 2 is already in factored form for you. So that's good. So you may want to pause the video, and once I've canceled this out, try it on your own. So we've got 3x minus 5 over x plus 1. So you've canceled out your common factor. So we're going to go through the y-intercept, the x-intercept, the vertical asymptote, horizontal slant. It would be best for you to practice these 4 steps and then check to see that you did them correctly in the video. So now I'm going to go through these steps. For my y-intercept, when I plug in 0, I get -15 in the numerator, +1 in the denominator. So 0, -15 is off our graph. I'm just going to put it down there so I know about where it would be. For my x-intercept, it would be at 5, 0. So there's my x-intercept. For my vertical asymptote, it would be at -1. That's where the denominator is undefined. And my powers of x again are equal, a linear over a linear. So 3 over 1 is 3. Y equals 3. 1, 2, 3 is my horizontal. And my whole, I canceled out those x minus 2's again. This is just a coincidence. Whatever you canceled out is going to produce the whole. So the whole is at 2. When I plug in 2, I get 3 times negative 3 divided by 3. Looks like negative 3. So when I plugged in 2, I got negative 3. No, that's okay. So 2 and then 1, 2, negative 3. So here is this bend. Oh, that was a hole. Oops, that should be an open circle. Here's this bend in the graph. So the other bend in the graph must go up here somewhere. It would be best to plug in a number like negative 2 for x in this function just to see where that point is. So 3 times, this would be negative 7 divided by negative 1. That's going to be at positive 21. That's way up there, right? So this is a pretty steep rational function up in that region. All right. So example 3 and example 4. I'm just trying to see the difficulty levels here. Okay, so we're going to do still example 3 and 4 just to keep you practicing because I know holes are new. But I think it's always good to pause the video and try the problem first just to keep practicing those skills. So here's one trick for you. If you see a factor of 2x minus 1 in the numerator and I tell you there's a hole, what do you know has to be a factor in the denominator? Doesn't 2x minus 1 have to be a factor in the denominator? So if you hate the box method, look for those little hints to help you. And so if you have to do 2x times something to get 2x squared, this would have to be x, right? And then what would you have to multiply to get positive 3, negative 3? Then you should check, does my outer plus my inner add up to negative 7x? Yes, it does. So there we go. Those factors do cancel, and I get 1 over x minus 3 as my function. So make sure that you keep that x minus 3 in the denominator. Now I'm going to do my y-intercept, my x-intercept, my vertical asymptotes, my horizontal slant, and my hole. Same steps each time. For my y-intercept, I plug in 0, I get negative 1/3. For my x-intercept, there is none. The numerator can never be 0. My vertical asymptote is at 3. X equals 3. My horizontal asymptote is at y equals 0. And the whole, what did I cancel up here? Where will 2x minus 1 equal 0? Won't that be at positive 1/2? So my whole is at positive 1/2. What do I get when I plug in positive 1/2 there? Let's try it together. 1 divided by positive 1/2 minus 3, negative 0.4. So at 1/2, I'm at whole at negative 0.4. So this is stretching this direction, it looks like. This is probably going in this direction. If I plug in the point 1, 2, 3, 4 up here, I get 1 divided by 1, which is 1. Okay. So I think this is going to be the last one I do with you. Actually, I might do example, one of these is harder. Actually, you are going to do number 4. You are going to do number 1 on the next page. Mrs. McCracken is going to do number 2 on the next page. Mrs. McCracken is going to do 3, and you are going to do number 4. All right. And actually, this I might do with part 2, actually. So, all right. So you're going to go back. You're going to do number 4. You're going to do number 1. And you are going to do number 4. The back page we're going to do as part 2 next time. All right. So, number 2. This is my last one that I'm going to do for you. Something special happens on this one because difference of squares, you know, x plus 2, x minus 2, x minus 2. What just happened? Do I have any function left in the denominator? No. My function is now the linear function x plus 2. Do lines have asymptotes? No, they don't. Lines do not have asymptotes. They still have x-intercepts and y-intercepts though. So I could still plug in 0 and see that my y-intercept is at 2. I could still set this equal to 0 and say that my x-intercept is at -2. And I can still find my whole. My whole would be at +2, because that's where this was undefined. When I plug in 2, I get 4. So let's graph this. 0, 2, -2, 0, and a whole at 2, 4. And it's a straight line, right? And it starts at 2 as my y-intercept, and it goes up 1 over 1. What's my domain and range of this function? So the only value for x that will never happen is x cannot equal 2. My only value for the range that cannot happen is y cannot be 4. I wanted to show you a quick example on the front page on number 2 of how you would write the domain and the range. These had asymptotes. So what domain value for x can you not have? X cannot be -1, and the range for this one would be y cannot be 3. So both wholes and asymptotes are going to be exclusions in your domain and range. So your work for part 1 is going to be page 1, number 4, page 2, number 1, and page 3, number 4. So you're going to submit a picture of those 3 problems on Google Classroom as your part 1 work for 19.